Hello guys. In this session of analog layouts, troubleshooting LVS and extraction errors, let's learn about some tips and tricks and techniques of debugging LVS errors. Okay. In a crude way, if you have to say a GDS and a schematic when they are compared, right? That's what we do in the LVS. But ideally, if you see, there are lots of things which goes in the background. As you can see in this picture, first device recognition happens for the layout, and then connectivity extraction happens, and then layout netlist is extracted. Likewise, you've got schematic, wherein schematic compilation happens, and then a source netlist is extracted. And these two netlists are compared together to give you the LVS results. This is a little more detailed explanation. Now, while we are running LVS, we come across lots of varieties of errors. So in this session, which would be very much helpful to all the beginners, mid-level guys, or some people, when you look into the whole index of this, you would get an idea like it can be helpful for all levels of expertise, wherein we talk in detail about what are all the varieties of errors, warnings, and all of it, and how do you figure it out, and how do you exactly spot the error and fix it. Okay, so the overall agenda of this session would be we'll start with a little simpler ones or call as pins and labels. Okay, everybody knows that, yeah, if at all there are pins, there are no pins, there are labels, all of it, you will get lots of warnings and port related errors. But there are different scenarios. What are the scenarios in which you get warnings? What are the scenarios in which you get errors? Okay, we need to have very clear. Now, things here, why it is defined and put across separately is because when you are debugging, you should rightly hit the spot. Okay, you would get to know the moment you see the error, you should know, okay, this is what it is. You need to go there and fix it. Right, and sometimes it also helps you in the interview as well. Right. So, and extraction warnings and errors. These are nothing but your ERC errors, which shows up as extraction errors, which is mandatory to be fixed. Okay. So errors, warnings, yes, can be ignored and later you can fix it. So what are these extraction errors? What are the varieties of these? When do you get these? Okay. What are the options what a layout engineer can do to debug this and fix? And what are the settings you can do in the caliber or your any physical verification tool for that matter to deal with these extraction errors? We've come across lots of incorrect nets. These are very common errors. So how do you figure out? The way the tool shows up to you, it shows some stars and it shows some missing thing on the layout side and the source side. How do you identify that? What is it talking? What is that script? What is that text message trying to convey? That's what we'll be trying to learn and understand in this. So while you're doing layouts, when you have to, fastly or fasten up your LVS work, you end up using something called as Virtual Connect. So is there only Virtual Connect by name, or are there any variants to it? What are our options to it? Okay, and if at all you are dealing with power supply nets, dealing with any other nets, all that stuff, we'll try to understand. First of all, understand the concept of Virtual Connect, where it is used, what's the importance of it, and what is mandatory and what's not. Okay. And then we would have come across scenarios where, sometimes you would have ended up swapping the pins. Okay. And it becomes slightly tricky to debug the error, but then still the error shows up. So are there any settings in the tool which you can set so that you can get rid of these errors? It will be easy for you to, pass through this pin swap related LVS error. We look into that also. Incorrect instances. These are very, very common LVS errors which we come across. Sometimes you get missing instance. Sometimes you get bad component subtype. And sometimes you get malformed devices. What is the difference between all these three? You have come across this. Probably you might have not paid attention to malformed device or bad component subtype. But majority wise, you might have faced missing instances. So when do you get these errors? What is that you have not done in your layout, or what you've done and kept in your layout that you're getting these errors, right? So we will try to understand and try to differentiate all these three kinds of errors. And property errors, which is, I guess, it's very favorite for everybody, So, but then, yeah, you do have some options of playing around with the settings to deal with these property errors. Now, another important thing here is opens and shorts. Okay. Now, this is something very important. Ideally, the tools give you a lot of options to, figure out opens and shorts. But the tool gives a message in the form of text, like this is an open, this is a short. How do you figure it out? You know, that's what we'll be trying to learn. Whether it's a short at the same level or whether it's a short at a hierarchical level, all the modules are clean, not clean, all of that you will be able to uh, learn in this session. But along with that, you should also be able to learn in this session what is trace nets. Whenever you're trying to debug a short, right, you will use some features in the tool. How to use these features, how to use mark nets. If there is a very big design, very big design, and you don't know where the short is, the short net is running through and through. What techniques should a layout engineer use, right? Or how do you figure out at what level of metal the short is happening, right? You need to know that. You need to know the tricks. How do you figure out? So we can use some features of these tools. We'll try to guide you on that and say that, okay, this is how you can exactly catch the error. Okay. Yeah. As you go, the EDA tools are, fastening up, they are getting more advanced and all. You've got lots of features in the tool. But then, yes, along with that, we'll see the legacy of these things, how, these things have evolved slowly and how it helps you debug all these errors. Okay. Moving further, we've got this concept of LVS bots. Maybe some of them may have used, some of them may have not used it, but yes, this comes in really very handy when you move towards the higher level of your design, a much higher hierarchy. How does this LVS box help? Okay, in what way it helps in moving towards the closure of your LVS? Okay, we'll study this, the scenarios and how it is used, all of that. Then there's something called as the HCL file. Okay, there are scenarios in your design wherein sometimes the library names what you've used, they don't match, even though the layout is same. If at all you have to convey some message to the tool to treat the cells as same between the schematic and the layout, you use something called as HCL file. We'll talk about this in detail. Plus, there are some other setting options what you can do, right? While you're doing LVS, or probably the enablement guy or the CAD guy can use these features to help you debug your LVS. These are some of the options what we generally use in Calibre, but then the options are almost same in all the other physical verification tools as well. So there's LVS option of A, B, S, and V, which we use to filter the devices when you short all the source drains and gates. And if at all you want to deal with soft connect errors or virtual connect errors, there are certain settings what you have to do. Only then you get those error messages, and that's where you end up fixing those. Okay, what is LVS case? Okay, case is something like your small ABCD and capital ABCD. So if at all you've got pins in bit capital B of 0, if at all you've written small b of 0, tool will throw you error. Okay. How to deal with that? Okay, and recognizing all gates, all of that, and when do you get this error LVS not compared? Sometimes the tool just crashes blindly, right? So you don't know where to look for what is happening over there. So that's one option we'll see. And LVS abort on supply error. So what exactly is this? When is this used? You may have seen this option while running the tool, right? But this is what it is. Along with this, as we go, we'll come across lots of pointers on which tool to use. I mean, not the tool, which courses you can take up, to help you these things, as well as what are the topics you might have to read to, pull up yourself on LVS debugging concepts. Conclusion, we'll conclude everything in a crux. So people who are watching this video on YouTube can, log into Semionics Academy and watch the whole session of this whole course on troubleshooting LVS and extraction errors. And if you're watching this course, this intro video on Semionics Academy, you can continue to the next video. Thank you.